quadratic function y is equal to ax squared plus bx plus c's minimum value, and the minimum value is a case when the a, which is a coefficient of the x squared term in terms of x squared plus bx plus c term, and then if the a value is positive, which means when the a value is greater than 0, the graph will go upward, which means it will look like this, and it won't, the maximum point won't exist, and the minimum value will right over here. And the x value is a case when you convert into a vertex form that makes the whole expression turn to 0, and the y value is a case when the left over. So this is a case when the a value was greater than 0, and let's talk about when the a value is less than 0. So first thing that we need to do also for this term is convert this term into a vertex form. The reason why we need to convert into a vertex form is because we cannot graph the exact value with this term because we don't know exact value of a vertex is, whether it is maximum or minimum value. So at first we need to convert it into a form, and if we convert it into a vertex form, think about this graph, same with this graph, but a different a value because the a value in this case was greater than 0, but in this case it was less than 0. And if this bx plus c's value are same, that means the graph form will gonna be same, but the format, whether it goes upward or downward, will gonna be changed. But in this case, the a value is negative, which means it is less than 0, and the graph will go downward. So we can just graph the same graph as right over here, but it will go to downward. So if we call this 0, and if we call this and we remember that the graph is going downward to look like this, which means only a maximum point exists, not a minimum point. So if you think about it, the here right over here, opposite with this one, that P comma Q will going to be a maximum point of this quadratic function. And for a graph of this function, so the graph will clearly gonna be opposite with this graph, which means P will gonna be stay there, and the only thing that changed is a y value, which in this case will going to be Q. So the case will turn into a positive, so they became a maximum point, and it is a basic format of a ax squared plus bx plus c's cases maximum value when the a term is less than 0. So if you make a dotted line in order to find a intersecting point with it, and this is a point P and this is a point Q, intersecting line is right over here, which means this will clearly gonna be opposite with this graph. So it will going to be like something that look like this. And this graph is just the approximation of ax squared plus bx plus c's graph, which the a value is less than 0, and when the a value and the b value as well as c value change, this graph can be changed. So if you think about an example of for this y is equal to ax squared plus bx plus c's graph, we need to convert. Let's think about an example of negative x squared minus 8x plus 10, and at first we need to convert this as a vertex form in order to graph a clear graph. So at first the only terms that we need to carry is the x terms, which is negative x squared and negative 8x. So I'm gonna put parentheses in it, negative x squared and negative 8x, and then something, and then plus 10. If you just think about this term in order to find the unknown quantity that I'm pointing out, there's a formula for it that we have learned is half of the x terms, which will going to be negative 8, and then we need to put square, and this is a formula finding this unknown quantity. And then this term we're going to cancel out as negative 4, and we get positive 16. So we can put a positive 16, but if you think about it, when the x term, x squared terms coefficient, which can be a leading coefficient, is not equal to 1, it's hard to factor it out. So we can just remove this negative by dividing the whole size by negative except for 10, because we're only caring about the terms that is inside the parentheses. So it will going to be negative. Negative divided by negative turn into positive, and then we get x squared. Then we get negative 8x divided by negative will turn into positive 8x. But negative 16, so positive divided by negative is negative, we get 16. But since we added 16, we also need to subtract 16 so that it doesn't really affect our original function, negative x squared minus 8x plus 10. The reason is because if we add 16, this graph, if we add it, it will going to be a 22, which is different with our constant 10. So, but since we added negative 16, but divide by negative will turn into positive 16. And then we get positive 10. And at first, we are only caring about a positive 8x. And if you think about it's 16, so the 16th factor, it is 2 times 8, and then 1 times 16, and 4 times 4. And if we add it, it should give us a positive 8, which means if we add 2 and an 8, it will going to give us 10. If you add this, it will going to be a 17. And if we add this, it will going to be 8. But we should get both of them, which means we also know that negative times negative turn into a positive. So we can turn 4 times 4 as negative 4 times negative 4. So if you convert it as negative 4 times negative 4, if we add it, it gives us negative 8, which satisfies our equation, but it should be a positive 8x, which means the positive 16 or negative 16 cannot work in this case. So we can only put negative in an x squared plus 8x plus 16. And then if in order to remove this, we can just add 16 to the both side. We get this term cancels out. We also need to add 16 here, and then we get positive 26. But we can factor this term out with negative. We get x and an x, which makes x squared. And then if you think about in terms of a 16, positive 16, that if we add it, it will going to give us positive 8. It will going to be 1 times 16, and then 2 times 8, and then 4 times 4. We have already learned that 4 plus 4 will gonna give us 8, which satisfy our terms. We can write plus 4, and then plus 4, and we still have a plus 26. But we know that we have negative, and the x plus 4 times x plus 4 we're going to cancel out as x plus 4 squared. And then we get positive 26. So we got our vertex form being raised. We got our vertex form through completing the square, that it is negative x plus 4 squared plus 26. So let's write it down here. And we can actually pick some points in order to create a function. So at first, let's find a vertex of our function. And for the vertex, in this case, it will going to be a maximum value because we know that a value will going to be negative. At first, the vertex is formed by x comma y. The x value is a case which is always should be opposite with the right one, and it is a case is 1, which means the opposite one should be negative 1. And we can simply think that the x value is a case which makes this whole expression turn to 0. And the x value is negative 1, and for the y value is the left one. And if we input it negative 1, this whole cancels out as 0. We get y value is equal to negative 2. So negative 1 comma negative 2 will gonna be our maximum value, negative 1 and a negative 2. And this was going to be our maximum point. So let's move our vertex form into here, x plus 1 squared and minus 2. And let's simply input some other values for our function. At first, for the vertex of this function, we know the vertex is formed by x comma y, and the x value should always be opposite of a value right side, which is 1, which means the x value should be negative 1. And this is a rule for the vertex of the parabola. And we can simply think about x term if we don't really know about the rule. We can simply think that the x value which makes this whole expression turn into 0. If you input a value of negative 1 plus 1 will turn to 0. Even though we square it, it will turn to 0. And we know that the left constant will going to be y value. But we already know that x value is negative 1 because we inputted value of negative 1. And the output of our function, which will going to be our y value, will going to be negative 2. So if you graph it, the x value is negative 1, the y value is negative 2. So it will going to be right over here. And this will going to be our maximum point since we knew that our a, which is our coefficient of the x squared term, is negative. That means the graph will go downward. And let's look at some points in order to graph the full function, full parabola. At first, let's think about the case when the x value is positive 1. When the x value is positive 1, it will going to be negative 1 plus 1, and then square minus 2, and that should be equal to y. We already inputted x value is 1, and then this term we're going to go to 2, and we square it, it will going to be 4, but we need to bring our negative down, so negative 4, negative 2, it will turn into negative 6. When you input a value of 1 into the x value, our output of our function will going to be negative 6. So 1, comma 1, 2, 3, 4, 5, 6. It will be right over here. And let's pick another point in order to graph a full function, full parabola. And let's think about the case when the x value is negative 2. When the x value is negative 2, we're going to be negative, and then negative 2 plus 1 squared, and then minus 2. And then this term we're going to go to negative 1. Negative 1 and the square we're going to be 1, but we need to bring our negative down. So we're going to be negative 1. And then negative 2 we're going to be our y value, which is our output of our function. Negative 1, negative 2 will turn to negative 3. So when you input a value of negative 2, the output of our function will going to be negative 3. So if you actually graph it, negative 2 and then negative 3, and then you will going to be right over here. So if you actually think about a approximate value of our graph, our approximate value of our graph will going to be made if you find more points in order to graph. And let's think about another point to graph. Let's think about the case when the x value is negative 3. When the x value is negative 3, it will going to be negative, and the negative 3 plus 1 squared minus 2 will going to be equal to y. And then negative 3 plus 1 is negative 2, and then squared will turn into positive 4. But we have our negative, so we need to bring down our negative, and we still have negative 2, which we're going to cancel out as negative 6. So when you input a value of negative 3, we're going to get negative 6. So in the negative 3, the y value will going to be negative 6 right over here. So we can actually think about the approximate value of a parabola that goes through these points. So this will going to be our approximate value of our function that satisfies this whole function that negative x plus 1 squared minus 2 is equal to y. And this will just gonna be approximate value because we know a full points for it. And this was function negative x plus 1, and then square, and then minus 2. That should be y. And we talk about the function x squared plus bx plus c, where a, which is a coefficient of the x squared term, is not equal to 1, is less than 0, which means the value of it will going to be a negative value.